Thanks for joining us today. I'm John Amond. I'm Professor of Chemistry Emeritus at Montana State University. I'm also President of MicroLab. I'd like to talk with you today about a new approach to hands-on electrochemistry labs. This will be a two-part video. Part one is a quick overview of 3 ways to make electrochemical measurements, and part 2 will use our new electrochemical half-cell module to run some quick Nernst equation demonstrations, the electrochemistry series, concentration, temperature, experiments of that sort. Electrochemistry labs and demonstrations are thought to be difficult and sometimes expensive. It takes a lot of different elements that transfer different numbers of electrons, solutions of ions of each element at different concentrations, at different temperatures, and you end up with a lot of material that you have to prep and have available on the table. Some of the elements are hard to find, expensive, or dangerous, but mostly it's just a lot of work. We'd like to show you 3 ways to make electrochemical measurements that are pretty cheap and easy to do. Now, the basic experiment starts with a citrus battery. We use a lemon, a lime, or an orange, and an iron nail, a galvanized zinc nail, and copper. And you can develop the idea of reference electrodes, reduction potential, and beginning to develop the electrochemical series with just this very simple material. The samples are wet, they're safe, they're inexpensive, they're easy to find. The second approach uses our Multicam Half-Cell Module. This has 8 wells concentrically around a central salt bridge. I put potassium nitrate in the center, potassium nitrate solution, and there's a porous cylinder separating the 8 cells. Each cell takes about 3.1 milliliters of sample. The salt bridge stays wet, and you can make measurements, very stable measurements with this, with 8 different elements of different element or different concentration. Our third approach, which we'd really like to talk with you today about, is our new electronic half-cell module. This has 12 different elements, including some that are quite dangerous, some that are expensive, and some that are hard to find. It's an extension of the prior experiment. It's fast, it's accurate, you don't have any prep time, and you don't have any spills. Here's a quick look at it, and you can see there's a salt bridge in the center. There are 12 half-cell modules around the outside, and here in a moment you can see we can set the concentration, we can set the temperature, there's a voltmeter, and there are reference electrodes. Here's a panel view. You can see again the similarity between the wet half-cell module and the electronic one. The 12 elements at 4 concentrations, 4 temperatures, 194 different half cells in here that you would have to mix up and have on your bench to do these experiments. You can change the concentration. You push this button, change it from 100th molar to 1 molar in decade steps. You can change the temperature in 20-degree steps from 5 to 65. You have elements such as gold and alumina that are +3, copper and zinc are +2, here's sodium and silver +1. You can show the effect of the N variable in the Nernst equation. There are 2 reference electrodes. On the right here, hydrogen sitting in the salt bridge, and here is silver chloride also. A voltmeter is built in. It runs on either MicroLab or a USB to a computer. You can flip it over for electroplating and electrogravimetric experiments. There's a 0 to 5 volt regulated power supply. It integrates the coulombs of charge or moles of electrons delivered, and it's overload protected. The advantages: it's safe, it's fast, you get quick graphs, low cost, no prep time. In the next video, we're going to take a look at this, and we're going to run some experiments, the electrochemical series, how reference electrodes work, Nernst variables, concentration, electron transfer, and temperature. So join us in just a minute for part 2.